What if you could run a physics experiment by talking to your computer? No dragging, no dropping, no clicking, just you and your AI tutor building a simulation real time. Please build a pyramid structure out of 6 boxes on the right side of the screen, then spawn a heavy ball on the far left side and give it a strong horizontal velocity to the right so it can crash us into the pyramid.
A pyramid of 6 boxes has been constructed on the right. A heavy ball is now positioned on the far left and is given a strong horizontal velocity to the right. The conceptual physics here centers on collision dynamics, specifically momentum transfer. When the heavy ball impacts the boxes, its kinetic energy is transferred, causing the pyramid to destabilize, move, and collapse.
For university students learning physics, the biggest hurdle is the bridging the gap between flat textbook math and real-world visualization. Traditional sandboxes are too complex, and standard AI chatbots can't interact with visual environments. So I created DrawDynamics, a real-time multi-agent AI physics laboratory. Instead of dragging and dropping, I can just talk to the AI and do a experiment. Let's set up a kinematics experiment. Please spawn a heavy ball on the left side of the screen with a horizontal velocity of 15 and show me the kinematics equations for its trajectory.
The heavy ball is now spawned. Conceptually, the trajectory is governed by projectile motion, where the horizontal velocity is constant and the vertical affected by gravity. The
We can run this generated simulation like this. Under the hood, the Gemini Multimodal Live API is handling the voice interaction, while the secondary Gemini Flash agents act as the architect and mathematician, translates my intents into JSON commands that manipulates the Matter.js engine and render hard-text formulation in real time. Because the AI has a constant state sync with the engine, it can act as a predictive outcome. So we can just add 2 objects like this. Then let's give them a velocity and a mass. And then let's click Analyze Simulation.
simulation unpauses, a head-on collision is imminent. The ball
It can also used to solve complex physics problems like this.
accelerates due to the force of kinetic friction, which is calculated based on the normal force and the coefficient of friction. Using Newton's second law, we find the deceleration to be 4.9 meters per second squared. Friction is work for the conservation of mechanical energy is potential energy initial plus kinetic energy initial equals potential energy final plus kinetic energy final. Conceptually, as the pendulum bob swings from the initial 45-degree angle, the maximum velocity is dependent on the pendulum's acceleration acting on the edge of the motor blade is AC equals W squared R, where W is the angular velocity and R is the radius. Angular velocity significantly affects the ball's new momentum because a higher angular velocity